Okay, let's continue our subject. Let me just discuss a little bit about my instructional plan for maybe today as well as next week. So I try to finish my lecture part of chapter 12 today. So I tried to finish the operator overloading as well as the move constructor, which is somewhat different from copy constructor and default constructor. I tried to finish that part, and then I'm actually going to move into chapter 13 and 14 together. So chapter 13 is about inheritance, chapter 14 is about polymorphism. And then we're going to address those two together. And what I want to do, blend it into my lecture at this point, is that I will be sometime talk about the lecture, the concept, and then immediately I switch to homework assignment. Homework assignment number 2 and homework assignment number 3, that's actually related to the lecture. Okay, so just to let you know that it's actually quite important for you to follow this lecture, because it's not only learning the concept, but actually give you a lot of information about how to do your homework assignment number 2 and homework assignment number 3. The other thing is that I will be still hosting the discussion next Monday afternoon, because I want to, now you probably see that homework 2 and homework 3 were both announced. In case you haven't noticed, I already adjusted the deadline for homework assignment number 1. Which is next Friday. All right. We finally resolved the issue with VPN, so we should be able to move in full speed, hopefully. So I would like to dedicate my Monday discussion to homework assignment number 2, just to let you know. So if you cannot make it discussion, it will be recorded, and please look at the recording. I just realized how I can help the student, because I would like to have more time to interaction. I think the Thursday afternoon, those, about 2.5 hours or close to 2.5 close to 3 hours. I think it's helping some of the students, because it's not only helping you, but helping myself as well. Through that interaction, I actually know what's bothering you, so I can actually address to a broader audience there. Of course, discussion is another office hour, but I realized one thing I should just let you know, that every single lecture in the morning, Monday, Wednesday, Friday, and usually I will just stay here and then go outside, just help you for half an hour up to 1 hour to help you to address all the problems. Because if you actually come to my office hour, sometimes it's crowded, but just use the time after each of the class, all right? And to get some help, it's not only help you, but help me as well, okay? All right, any question before I continue today's lecture? Okay, so we talk about this 3 constructor, default constructor, copy constructor, and move constructor. The main difference is the move constructor is actually sharing exactly the same pieces of memory they're using. Okay, that's the main difference. So I thought I have a let me actually bring up one of I have a picture somewhere. Forget it. I would just go over that. So I actually, in the process that I introduced a new syntax, which is similar to malloc, but it's called new. That's the new thing of new and delete. That's actually corresponding to malloc and free in programming language C, to help us to dynamically allocate a chunk of memory. But in new and delete, it's actually helping you to manage the memory, but in the granularity of object. All right, so when you say new, whatever class X, say that new could be new box or new person. And then it basically helps you to allocate the memory that's actually enough to support a new object box or new object person. And then at the same time, it will invoke one of the constructor. So depending on what I actually put it there in this parenthesis, it might actually invoke default constructor. It might invoke copy, or it might invoke move constructor, depending on how you call that. Okay, so that's the only difference between new and the malloc. So malloc is just give you the memory without doing anything, but then new is actually give you the memory and then it will call one of the constructor. All right, at least one of the constructor. Okay, when you learn inheritance, you will realize it actually might call multiple constructors. It's not only calling the constructor of the current object, but calling the parent object as well. Okay, the constructor. We'll see that very soon. The other thing about new is that when you actually usually create an object, it's just an object. But when you use new, just like malloc, the return of new or return of malloc is a pointer. It's actually an address. It's an address pointing to the memory chunks or memory region that allocated for the object. Okay, that's the new syntax about new and delete. All right. So now let's look at some of the example I want to show you. So you already see this. I thought I already showed you this code. So I'm going to skip this part, but I want to, oh, okay, I know what I want to do. I actually have this is the left-hand side is the piece of code that's actually including the three constructor. The right-hand side is the driver, is the main program that's going to create some object. So we're going to see different convention, and then you will see that which constructor will get called. So the first case, pointing by the red arrow, is linking the statement that create an object that's going to invoke default constructor. You can see that if you define something like a data A, if you define data A, then that's going to be a default constructor, because if you match the signature, the default constructor has nothing. The copy constructor is data n%, 1n. And then the m, not n%, sorry, m sign. And then the move constructor, if you call it, was 2n sign there. Okay, so that's actually the default constructor. And this one, the second statement, I hope you can see that, it's kind of small. The second way of calling it, you see, that's a copy constructor, because I create A already, and then I basically just calling it, and then I use something I call casting. Okay, this is something which is some of you probably familiar with when you use programming language C. And this is going to be the same as you will be using in programming language C++, is you can actually tell the compiler how you want the compiler to view this data type. So I actually, if you look at this statement here, data B, and then I'm actually putting parameter of A. But that A important, I cast it as data 1n. So that is make that A become, is still the object, but it's actually casting as a type. It's a reference to the data. Okay, that is just a casting. So it's not a pointer, it's just a type that changed from the value type to a reference type. So if you have that, that will actually match what we call the function signature. So essentially in C++, how do you know that this function should be called? Is completely determined by what we call function signature. What is function signature? Is the return of the function, the data type, plus the input arguments data type. they match exactly, as well as the number of arguments, of course, then basically you will match. If you have a two function defined sharing exactly the same function signature, then the compiler will throw an error saying that you actually redefined the same function. Okay, that is very unique in programming language C and C++. Okay, so you can see that if you define that way and casting this. So now let's look at the third line. If you do it this way, I mean, if you look at this, this is exactly the same. If you forget about the casting, it's the C to the parenthesis A and the B to the parenthesis A, they should be exactly the same, right? It's exactly the same variable that you create earlier. But because of the casting, you kind of redirect the call to yet another type of constructor called move constructor. So essentially, you put that as a 2n there. And therefore, it recognizes, okay, you have a double reference there. If it's double reference, okay, I'm going to invoke this one. And that's how you can, okay, I'm actually telling you two things. Is number one, you define the constructor differently, and then you can actually invoke the constructor differently as well. So it's a pigeonhole, okay, one versus the other. All right. Any question before we actually try to run this program and see the result somewhat different? Yes, please. This one is the main function. Is that your question? How they're related to each other? Okay. So, of course, this file is include, say, we have a file called data.h and data.cpp. So data.h basically give the definition, the top portion of what is, in fact, this should be data.h. Okay, the whole thing is included by this program. This program is called driver. I'm actually include the class definition so I can actually really use that class. So the difference, if I understand your question, please let me know if that's not the case, is that when I declare how a class should look like, the driver program basically utilize something other people already created, and I'm actually writing the program to create a bunch of objects according to the spec over here. Does that answer your question? Or I heard you say star somewhere, which is okay. All right. Yes, please. You said this one, right? Let me just this one, right? Yes. Yes. It basically, because it's a copy constructor, it will just simply copy the value of A into B. Yeah. But the difference, I just want to leverage your question, extend a little bit. But copy constructor is not copy the value, but they actually share the same memory location. It's about this value pointer. Is that they actually share that integer with a previous object. That's a very significant difference between copy constructor and move constructor. All right, so I'm going to ask you to try to do something. Okay, pull out a piece of paper or whatever. You can do it on your just look through the code. And I have a 6. You see, I have a 6 cout statement in this code, right? I have 1, 2, 3, 4, 5, 6. I have a 6 cout statement. I want you to do something. I want you to tell me what should be the output of this last 3 statements. Look at the code and tell me what number that number should be. Okay, remember I actually have a statement of assignment here, and assignment here. Okay, so I give you 30 seconds. Maybe take a look at the code, and of course make sure you understand. And if you have any questions, let me know. But try to see what do you predict of that 3 value. Yes. See, there are 3 cout statements. It's like printf. What do you think will be printed? The value. This value. What should be the value that got printed? This 3 statement. What? After you execute the program, right? After you execute the program, run the program, it's going to eventually print this 3 value. I want you to see before you actually run the program, what should be those 3 values. Okay, maybe let's try to do. So there are only 3 possibilities. Each of the variable could be one of those 3 values. Either it's 111, 222, or 323. Okay, either one of the 3 values. So the first printf statement, what should be this value printed here? This one. What should be the value printed here? Is that 111, 222, or 323? Okay, hold on to your answer. I'm going to show you the result next slide. How about the second one? How about the second one? So 111, 222, or 333? How about the third one? Let's actually do a vote on this, the third one. The third one, should this be 111? If you think it's 111, raise your hand. If it's 222, oh, 111. If it's 222, raise your hand. If it's 333, raise your hand. Okay. All right, let's actually see. That's okay. I mean, to be honest, if you ask me the same question, what I will do is give me 5 minutes, I type in the program, just run it and get a result. That's pretty much the spirit of program. Yeah, you have a question? Okay. That's why part of the question I want to ask is copy is, if I do, let's make a case here. Assuming you're actually thinking about what restaurant you want to go tonight. Assuming like that. What's your name? Your name? Yochen. Okay. Yochen, if you think about what restaurant you like to go tonight, just pick one. Which one? Oh, the Cantonese. That's too challenging. Okay. I know there is a very good Cantonese restaurant called Tasty Kitchen in Sacramento. That's my favorite. No, there is one in Vegas, but they're the same. But there are certain dishes I really like. Is only served in the Sacramento one. The Sacramento in Freeport, and I think is what's the in the Freeport? I forgot. I mean, I know how to drive there.
What's your favorite at this one? One of your favorites.
I like that. If I don't want to drive, I will go there. the tasty kitchen. Okay, assuming you wanted to go to whatever restaurant, Cantonese restaurant, okay, in Sacramento. So if I can copy Constructor, I actually initially, when I copy you as object, so from you to me, initially I want the value, say I want to go to Cantonese restaurant. But then you change your mind, you say I want to go to Burgers and Brew. That's in Davis, right? I mean, that's another of my favorite restaurants. Okay, assuming you change your mind to Burgers and Brew. Under copy Constructor, I'm still in Sacramento, Cantonese restaurant. But move Constructor, when you change, I change as well. That's the difference between move and copy. Means that I'm actually, we're sharing the same memory region. Is that kind of explain the difference between those? So okay, I actually recommend you, when you look at object-oriented, this is excellent question. What's the difference between this and this? Use a real life example. It really helps us to understand what's going on. There's a reason mimicking the real life situation there. Okay. All right. So here is the answer. If you look at the answer, the first one is a 333. The second one is 222. The third one is 333. So it shouldn't surprise you for number 2 and number 3. It's 222 and 333. But it will surprise you is why the object, the first object, A, becomes 333. Okay, let's go back to the code. If you look at the code I showed you earlier, the value of A was say a Cantonese restaurant in Sacramento. Okay, that's A. Okay, so now I'm going to do move Constructor. Now this becomes Felix Wu's mind. So when I actually change to 333, I change to Burgers and Brew. It changed his as well. So shared memory is not just his change influenced me, my change influenced him as well. So it's so convenient, right? If I get a bribing by Burgers and Brew, they want to say, hey, influence all your students. I will use move Constructor. Okay, it's very easy. I can just put it in your mind. That's so convenient. Yeah. Okay. Yeah. What? What is the value? Oh, okay. I got it. Sorry, I thought you were saying something else. Yeah. So this is the 3 value here. This is the 3 value. You see 333, 222, and 333. This 3 value. So this is the value for A. This is the printf value for B, and this is the value for C. You see that A's value was 111. It's still 111, 222, until you call that move Constructor. When you call that move Constructor, it's dangerous because there will be another object, just like a call by reference. It can actually access to the same memory region. Okay. Yes, please.
So what's the syntax for move Constructor to ampersand?
Yeah, it just try to differentiate. We try to differentiate so we got called different. Yes.
So what about the syntax for the move Constructor versus the copy Constructor that determines whether it's a shared memory or it's a copy memory? Like which of the lines?
Is a shared. If you look at the line here, you see this part is actually, I'm actually copy. This line is copy Constructor. Say A data, right? A data here is actually the parameter of the copy Constructor. And when I try to copy the value, I actually look at you see what I did? It's a star value pointer. Star value pointer means the content of whatever I have. I actually copy the value. So this line is actually just copy the value. It's a little bit pointer syntax. If some of you are not familiar with C pointer, this is the time you might not understand, but that's okay. I can go over this again and again for those of you, or you can actually look at capture the pointer syntax there. Yeah. Yes, before that line, yes, b dot star, b dot the value pointer is 111, right? But this one you assign. So at this point, before you execute this line, if you actually print the statement that the object B, the value is 111. But after you've done this, it became 222. Essentially, C is here, B dot value pointer star. So anything star means that the content, I want to assign the content to whatever value I put on the right-hand side of the assignment statement. This is the assignment. Yes.
Just checking something. So like the data reference, the data double reference, they're all kind of the same, but are just considered different types for the purpose of
That's exactly. This is, yeah, you're right. Using the casting. So sometimes it's confused. Yeah. This is different from, say, in pointer is integer, integer star, star. The value is going to be totally different. But this is actually the same, just type different. Yeah. Yeah. Don't get confused. That's why the C programmer sometimes got confused in this situation. Yeah. Yes. Depending on what you want to do, if you want me to share the memory status with the other person, then you want to, whether you want to share the memory. So the real benefit is, let me put it differently, is that whether you want the old object still have the influence to the new object after it was created, and also vice versa. If that's the case, then you want to use move constructor. However, if you just want to copy the value at the time to the new object, and after they got created, they're basically totally two different lines. Then basically copy constructor. That's the reason why we want that copy. I think we want it. Yeah. Right. You're asking this line, right? Sorry, move my mouse. You're asking this line, is that right? Okay, so compare this line with this line. This is a move constructor. Both sides doesn't have a star. And that one, both sides have star. So what is that star is doing? What?
Pointing.
Sorry.
So I said it's a pointer, yeah. So the star is the pointer.
In fact, if you let me explain a little bit the syntax. What's the difference between star and no star? Is that if without star is used as a pointer, because the value pointer is actually the pointer. It's a pointer to an integer. But if you put a star in front, it essentially cancels that star over there. So it became integer. So this one is a pointer, value PTR is a pointer, but star value pointer is the content, the value that the pointer is pointing to. That's the difference. Okay. Yes.
I'm wondering what happens to the actual value that the first and the third one are looking at.
What's the value?
You know what value pointer is one?
Right.
Does when we call the constructor for one of them, does that hit value the no pointer or allocate that to all of them?
You talk about move constructor.
Yeah, for the move. Will that that coming from?
You delete which one?
Either one. And then the other one.
Oh, I see what you're saying. Okay, that's a good point. That's a good point. You see that I have, this is called destructor. I have a destructor, but the destructor, you see, I comment out, delete the value pointer. You see that? This is the place which why I actually comment this out, because if this is a move constructor, if I delete this, then essentially the other one is going to have segmentation faults. You see that? So that's an excellent point, actually. I like that because if I only have copy constructor, my destructor is much simpler. I just remove everything. But whenever you have that double pointer or more than two pointer pointing to the same location, that this delete has to be very careful. Yes.
I think I remember something. What was the classical, like, did that properly or something? Like, did it well? I think it was like
I don't know. I don't know what that was. I probably forgot. If you can.
the point is, I want to do it. I'm pretty sure something else will good for it.
Probably not in C++. Probably not in C++, because C++, we are not tracking how many pointer pointing to the same location, because the address can be copied to somewhere else. Whenever you make your references count become bigger, the language itself doesn't provide any protection. That's why C is worse than Java. Java, they actually keep tracking. So in Java, they do garbage collection. As long as they realize there is no pointer pointing to this memory, they free it. That's the main difference between the design of Java and a bunch of other languages like C++. C++ doesn't provide garbage collection. And so that's why Java program is actually more robust, but it's more expensive. A bit slower. Actually, Java, if you do it fast, you can get it really fast. Yeah. I mean, Java is going to be faster than Python. Python is an interpreter language. Yeah. Let me see a question. What? If you don't allocate, I mean, in this case, I actually allocate the memory at the first over here, right? If you don't do this, and when you try to dereference that pointer, it will cause what we call segmentation fault. So let's give you an example. Yes, you don't have to, but you better not use that memory. You don't have to, but you don't have to. I mean, some of you actually got segmentation fault over example number 1. The reason you got segmentation fault is you use fopen. You open a file, but that failed. So whatever the pointer returned by fopen is null. And then you try to call f3 or fwrite on that pointer, you got segmentation fault. That's the same thing. If you don't use it, it's okay. If you use it, you will have segmentation fault. Question here?
Yeah, so destructor.
Uh-huh.
You put a star in front of value pointer, both of the objects that nothing in the actual they have nothing to access, but they would exist, but if you don't have the star, there would be a segmentation error.
You say here?
Yeah, if you put a star.
Delete star?
Yeah.
Well, delete specifically it should apply to a pointer to object. But if you put a star, become a content. But depending on what's the data type of value pointer, if the value pointer is a pointer to a pointer double to another object, then this will be. Yeah. Okay, I saw there was a bunch of hands. That's good. Yeah, go ahead.
Value pointer is the pointer.
Right. The pointer to an integer.
So new is part assigned to that point.
Exactly.
Even if I like take the end value point right, and then value take you and star that will same thing.
Say it again. I got a little bit captured. You said what should I do over here? Sorry.
If I initialize the end as just value pointer, right? Like first line, public,
This line.
and then take the others as star value pointer. That will same thing.
What should I do with the first line?
Star.
Remove the star. Okay, that becomes the integer. Okay. Then what should I do?
Second the time to make the other value pointer star.
Other value pointer. You mean this one here?
Whenever there is not star, I add star, and whenever there is one, I remove.
Okay, so you're saying that if this one has a star, I remove it. And there is other place you want to add a one if there's no star. Okay, it probably won't work. I cannot tell you exactly because there are so many options with that star. It probably won't work for the following reason. If you remove this star, this is actually value pointer is no longer a pointer. It's just an integer. Okay, assuming the integer is exactly the same as the size of the address, so it means that the memory region is still the same. You can still use that integer as an address if you do the right casting, but it's complicated. But if you come over here, let's say this line, you're saying that I want to do a star, something like that, right? You're going to do a star. And it probably won't work because this is a new int. Because the value pointer, if you treat it as a memory address, then star value pointer is going to point into that content. Because the value pointer initially most likely looks like it's a 0. So it's a null address. When you add a star at this point, if you add a star in front of here, if you add a star here, that will trigger a segmentation fault. If the value of value pointer at that point is 0, you try to reference address 0. In case you don't know, there is okay, just to let you know, this is very interesting. You should learn more on ECS 150. Is all the memory address being separated into different regions. Certain region is only be useful by operating system kernel, and certain memory region address is only useful for user program, like the program you write. But the design of Unix operating system, they know the number 1 error people committed as a crime, okay, as a C programmer, is a segmentation fault. That's how serious I put it, okay? It's like committed crime if you have a segmentation fault. It's a good crime, actually, look. But they know this is the most commonly crime that every C programmer committed. So in the operating system, they actually make from 0, 0, 0, all the way 0 to the first 1K file memory address. Nobody can use it. Not even the operating system kernel can use it. Reason why is because it's just because if you make a mistake, you trigger that area. I know you're hitting something which is completely bogus. Yeah, that's the reason. And you will wonder now. Well, then I'm wasting 1K memory. No, you won't. You won't, because the virtual is a concept called virtual memory. Is just a virtually you lost that 1K, but physical memory, everything is the same. It's a design beauty of operating system kernel. So in some sense, the Unix operating system, it really ties closely with the C language. It was developed together, these two concepts. Okay. All right. Any question? Yes.
How would you go about properly bringing data?
Right.
I
Yeah.
In a destructor like, in the destructor class that has.
Right. There's no silver bullet. So the programmer has to worry about that. So essentially, you're the programmer. You cannot rely on one single destructor like this to either delete all the memory you allocate or not actually causing segmentation fault and just writing one. So you have to do some kind of tracking. You have to actually track how many. I mean, for example, we talk about object count. That is one mechanism because I can actually count if all the object I create using the move constructor, I will actually count in the destructor whether the object count is go down to 1 or 0. Then at that time, I can actually read. So the programmer needs to understand this logic. But just contract to emphasize again, if that's the case, you really want to do your programming, maybe Java is better programming language in that sense. Okay, so I think I have enough here. So I actually mentioned this is the issue. Either you're going to have a segmentation fault or you're going to have a memory leak. Okay, that's the issue we need to worry about. Okay, I think I'm done with the constructor. So now I think I cover all the topics I want to cover in chapter 11 and 12, even though I didn't cover everything, but the rest, if you have any question in your textbook or whatever, you can actually bring it to my office hour to ask me. Okay, so I'm going to move to my next one. I still have 7 minutes. Hold on 1 second. Where's my, oh, sorry, not this one. Huh. Oh, here. Okay, I'm actually going to move to my next topic. It's called inheritance and polymorphism together. And this is probably going to take probably going to be like a 5 lecture on this topic because this is probably more complicated. And now we're actually looking at both chapter 13 and chapter 14 together on your textbook. Okay, so I want to start to tell you the basic. There is a lot of things I can talk about inheritance, but my first level instructional objective is want you to learn the most basic, simple way of doing inheritance. In fact, that's the most commonly used inheritance in a programming language, any object in the programming language. Okay, so inheritance essentially let me actually tell you what's the philosophy, and then we can actually come back to talk about this. Sorry. Here. This is a slide I want to tell you. So inheritance, you can see that it's a relationship between 2 different classes. And one class is what we call the base class. That's a class to be inherited by another class, which we call a derived class. For example, you say a person is a base class, and then a student is actually could be a derived class from class person, because a student is a person, but then the student have some extra characteristics we can model on top of just being a general person, because you have homework, you have your responsibility to come to school and things like that. Okay, so that is the basic idea about relationship between two classes. One is the base, one is the right. And usually I will use what we call is a relationship. Is a means that a student is a person. So when we say derived class and the base class in the inheritance, we're saying that an object from a derived class is actually an object of the base class. So that's why we call it is a relationship. Okay, just this is still concept. I haven't teach you anything about how you're going to represent this concept. So the reason for inheritance, again, has two different purposes. I already talked about these two purposes. Remember, when I talk about object-oriented, I said object-oriented is great for modeling a complex system. And object-oriented is also very good for have a better software engineering, software developing. So the same thing for inheritance. So inheritance also has a modeling perspective. It actually captures the relationship between our society, between the system we try to model. So you use is a relationship. Think about how you can quickly apply this is a relationship to your life. For example, you can say Tasty Kitchen is a Cantonese restaurant. A Cantonese restaurant is a restaurant, right? So you can actually do is a relationship already among all the restaurants you have been visited. All right. The second part of the is a relationship is what I call co-reuse, because you already developed a lot of method, a lot of attribute in the base class. So it will be very easy for you to just inherit. So when you inherit, that's conceptually inherit, but you inherit all the specification you actually put on the base class as well. So in some sense, it helps you to shorten the software development. Okay, there are two goals here. One is help you to save your programming time, but then to capture the real system you try to build. Is that clear? Okay. Again, I posted a link over here. Sorry, it's blocked a little bit, but this link actually provides every single detail about C++ multiple inheritance, and which I don't think I want to talk about right now. I don't think you need to use very much there anyway. Give me 1 second, okay? I'm finished here. But I want to, starting next Monday, I'm going to talk about this 3 questions. Is that, well, based on this concept, how do I actually use the linguistic of a C++ to define a derived class? And how do I actually manage the relationship between parent and the derived after you actually inherited? And also, how do you actually interface the object under what we call class hierarchy? When this is a relationship, it's become more and more complicated. It looks like this. For example, it becomes a tree. This is, if you think about this graph, this is just a tree totally from community member all the way to teacher to whatever you have. Okay. All right. So you all have a good weekend, and I will see you on Monday morning. Yes, you have a question? Very, very similar. A little bit different. Very similar. Yeah. Can I turn off the recording first, and then I can just give me 1 second. Hey, how are you?
I love my power supply.
I saw that. This is yours. You're welcome. Yeah, I figured that must be yours. Plug in there.